In this tutorial, we are going to be discussing vectors. Vectors is a topic that you will meet not just in mathematics, but also a very important topic in physics. So going through this lecture should give you all the required knowledge base to tackle all the questions in both your physics and mathematics exams. The minimum criteria to show any secure understanding is to be able to distinguish between scalar and vector quantities. This is a common objective in both mathematics and physics. An intermediate level of understanding, one should be able to describe a change of position as a column vector. Remember that describing a change of position in mathematics, we use the terminology translation to describe that. Now, to show secure understanding of vectors, you should be able to solve mathematical problems involving vector algebra. Key concepts. A quantity is defined as scalar if it has a size but no directional properties. Examples can include length. Now, a length of a pencil can be 1 meters or 2 meters, but it cannot be -1 meters or -2 meters. It only has a positive value. Area, volume, speed, mass, density, pressure, temperature, energy, entropy, work done, and power are just a few examples of scalar quantities. In this quantity, there is only one possible direction it can go. So the direction of movement doesn't really matter. That is to say that if a square has an area of 4 meters squared, then it doesn't matter where that square is. It's always going to be 4 meters squared. There is no change in value or property based on its orientation or direction. The other key concept in this lecture is vector quantity. Unlike scalar quantities, vector quantities have both directional and magnitude. Directional properties and magnitude. It must have a magnitude and direction. Examples include things like displacement, velocity, weight, right? And in this case, when we talk about the weight, we talk about the weight as being a product of your mass and gravitational pull. Acceleration, force is a very important one that appears in physics as a vector quantity. In physics, you'll be expected to draw force diagrams. Drag, lift, are just a few examples of vector quantities. During your study of physics, you will have to use and apply the scalar quantity idea and the vector quantity idea and distinguish between scalar quantities and vector quantities. In physics, there's a lot of vector quantities involved in drawing force diagrams, in resolving questions to do with momentum, in looking at forces on a plane and forces on an inclined plane.